Now that we have covered RDDs in Spark, it is time to look at another data structure which is built on top of them, and this is the Spark data frame. It is easiest to think of data frames as a tabular rendering of the data in an RDD. To understand, we revisit the table which we saw previously. So this is one which contains 6 rows and 4 columns of data, and this is exactly what a Spark data frame looks like. So for those of you who are familiar with the Pandas library, data frames in both Spark and Pandas are very similar. So here, one record of data in a Spark data frame is the equivalent of one row in the table, and a field in a data frame corresponds to a column. So why exactly do we use data frames instead of just plain RDDs? Well, this is because it's usually easier and more intuitive to work on structured data such as a data frame than with raw RDDs. So data frames were not available in the initial versions of Spark and were only added in version 1.3. Since they are built on top of RDDs, data frames are also immutable and distributed across the nodes in the cluster. One feature of data frames is that the columns within it have names and we can reference them using those column names or headers. And for those who are familiar with relational databases, it is often easier to imagine a data frame as being conceptually similar to a relational database table. One thing to keep in mind when using Spark data frames is that there is no type safety at compile time. So unless you're careful, you may run into runtime errors when creating data frames. And finally, Spark data frames are available in all the supported languages. That is Python, Scala, Java, and R. And also, since data frames are simply higher level abstractions on RDDs, they share the same qualities. That is, they can also be partitioned across the nodes in a cluster, they are immutable, and they are just as resilient as RDDs.